This is Holloman Air Force Base, Missile Development Center, Alamogordo, New Mexico, North Range Hardsite area, where weapons and men are field tested. Weapon systems must be proved operational, and every weapon system must be guided, either in the air or from the ground. In the spring of 1959, this simulated atomic blast-proof building called a Hardsite was ready for testing. The Air Force had appointed North American Aviation manager of a joint F-100 MACE program to obtain basic data for the design of operational Hardsites. Now, if proven feasible, Hardsites could be hidden in forests, mountains, or other strategic spots to provide atomic blast-proof launching sites for missiles and airplanes. The plan was to rocket blast the F-100 and the Martin Mace out of the building from zero-length launchers. This concrete and steel replica of a Hardsite shelter was designed for the program with separate compartments for the Mace and the F-100. While instrumentation and high-speed cameras are installed, the Mace is readied for the countdown. Special instruments are needed to gather information on acoustics, gas composition, vibration, engine operation, and pressures within the building. While Mace launch tests continue from one Hardsite compartment, its companion cell is readied for this dummy Super Sabre, made of 20 tons of concrete and steel, and sporting actual F-100D vertical and horizontal stabilizers. It will be launched from the Hardsite to obtain full-scale acoustic, pressure, and gas composition data. Both vertical and horizontal tails are instrumented with accelerometers and sound pickups. The dummy's lifespan will be only a few short seconds. In that arc of time, instrumentation will reveal the secrets of this unproved environment and assure the success of the piloted launch. Beneath the Iron Bird lay the reinforced concrete floor. Acoustical fiberglass insulation lines the walls to absorb blast energy and sound waves. The vertical stabilizer would prove it could clear the overhead during the launch. A steel exhaust tunnel, 10 feet in diameter, was built to carry off the rocket blast. Engineering studies and scale model tests resulted in this prototype tunnel. This configuration will get its first test in exhausting the rocket blast without damaging the structure or affecting the launch of the Iron Bird. Transducers are installed to measure the air pressure from the blast in the exhaust tunnel and inside the walls of the Hardsite. Rocketdyne's solid propellant rocket booster, packed with 130,000 pounds of thrust, is readied. After installation, the booster will be accurately bore-sighted. The same techniques will be used that had been perfected on the outdoor Zell launches. Closed-circuit television cameras stationed in the Hardsite transmit the picture to the blockhouse monitors. These screens give engineers their last look inside the shelter before and during the actual blast. All instrumentation data-gathering devices are primed. The dummy is raised to the 18-degree launch angle, and the final countdown starts. The extreme nose-up pitch would not be acceptable if this were an F-100D launched for a mission. However, study of the trajectory, the line of flight, revealed that the tunnel mouth should be enlarged from 11 to 16 feet. 2 months later, number 2 dummy is ready. A slight pitch-up is noticeable, but further enlargement of the tunnel mouth should ready the Hardsite for the first piloted launch. As modifications begin on the Hardsite, North American engineering test pilot Al Blackburn flies in from California. This brings together the veteran team of Blackburn and supervising flight test engineer Frank Munns. Previously at Edwards Air Force Base, they had proved the mobile F-100 Zell feasible. Now, they will prepare for the piloted phase of the Hardsite launch. Data from the dummy firings pinpointed the problem. The tunnel mouth must be enlarged to 18 feet. The first launch had indicated that the dummy's objectionable nose-up pitch was caused by booster blast. The blast reduced air pressure inside the building, sucking in outside air. This secondary airflow pushed down on the dummy's horizontal stabilizer with a velocity of 145 knots. The tail went down, and the nose pitched up as the dummy shot out of the Hardsite. Now, with this structural change, the downward airflow on the horizontal stabilizer will be lessened, and therefore reduce the plane's angle of attack, smoothing out the launch. Besides the pilot and engineer, a third member of the veteran Zell flight test team is in New Mexico. The familiar F-100D number 947 will be towed from the airstrip to the Hardsite area. Reliable 947 has had 18 successful open-air launches. 5 of the launches were with Air Force Captain Titus, and 1 with Lieutenant Colonel Lane. Titus had Zell launched 947 at the Indian Springs weapons meet. Blackburn already has air-launched 947 12 times. Now he and his airplane are scheduled for 2 Hardsite test launches. Modifications to the cave-like building are complete, and the F-100D is towed onto the launcher. The world's shortest runway is ready. The launcher is a self-contained airbase with the necessary electrical and hydraulic power for servicing the airplane, including a pneumatic engine starter system. The booster, which weighs 5,400 pounds, is lifted hydraulically. There is only a 2-foot clearance between the wingtips and the walls of the structure, so bore sighting procedures developed on the dummy are carefully followed.
Time is T minus 30 minutes. All unauthorized personnel, please leave the area. I say again, all unauthorized personnel, please leave the area.
Munns and Blackburn rechecked last-minute flight plans. The dummy firings had answered many of their questions and eliminated most of the expected risks of launching. But they realized that this will be the first time that exhaust fumes from the jet engine will be added to the rocket blast in the Hardsite. This will also be the first time Blackburn and the airplane will be subjected to so much noise and vibration. Air pressure against the building's interior walls will be tremendous. Engineers have worked months perfecting this concept. Only the test flight remains to prove it operational.
The time is T minus 15 minutes.
Al Blackburn has a veteran flight test crew behind him. His 7 years of experience in jet testing with 14 open-air Zell launchings are also behind him. Less than 7 minutes now. Methodically, each step is checked off. It seems routine, except for one fact. A piloted aircraft has never been fired out of a building. Instead of this test launch from a simulated structure, conceivably, this could be an operational Hardsite built in a mountain cave or located in an underground bunker. Safe from the blast of an atomic bomb, the combat-loaded Super Sabre could be rocketed into the sky to assure retaliation. Blackburn sets the trim and checks his controls. Engine power is brought up to 100%. Al is satisfied with the engine check.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
booster falls away only 4 seconds after takeoff. The purpose of the Hardsite program has been accomplished. Here is a manned airplane shot out of an atomic blast-proof base, ready for combat. Later, Blackburn reported that he had no problems during the boosted portion of the launch, using only his instruments. It seemed smoother than any previous launch. During the blast, vacuum bottles in one instantaneous gulp trapped the explosive gases. Field analysis of the collected gas samples in the shelter and the exhaust tunnel reveal that gas concentrations do not reach an explosive level during or after launch. 1 week from the day of the first F-100D launch, uncertain weather hangs over the North Range as rain squalls surround the area. The successful Hardsite launch left only one question. Would pilot techniques for day launches be valid for Hardsite night firings? The ease of the first launch prompted Al Blackburn and the engineers to switch the second launch from day to night. At midnight, the crew is at work. Official sunrise is 5:34 a.m. The launch must go before then, or it will be too light for a night try. Instrumentation, bore sighting, and other preparation proceeds exactly the same as for the day launch.
All unauthorized personnel, please leave the area.
For Blackburn, everything is the same as the day launch, except for the absence of light.
The time is T minus 15 minutes.
At 4:45 a.m., Blackburn sets his red instrument lights full bright.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
While the rocket burned, the pilot held his course, guided only by cockpit instruments. Day or night, safe from nuclear blast, Super Sabres launched from Hardsites strengthen the U.S. arsenal of retaliatory weapons.